Okay, so this video is to help you make your word problem. So I made up a word problem, and it says that Mr. Toops is using his time away from school to increase the amount of miles he can ride his bike. Initially, he could ride 6 miles, and every day, he doubles the miles he rode. So let's talk about some keywords. Some key things you need to make sure that are in your word problem are some kind of initial value, and there needs to be some kind of what we are going to call a B value, or something that occurs. So like in mine, he's going to double it. And so when I go down below, it says step 2, identify the important information. So my starting value is 6, and this is my A value. It's my initial value. And then my growth or decay value is 2 because I'm doubling. And double means to multiply by 2. And this is my B value. Oops. This is my B value. And so when I put these two pieces together, I'm going to plug in my A, which was 6, and my B, which is 2. I'm going to write my equation. I'm going to have Y equals 6, which was my initial value, times 2 to the X. So this part down here is step 4. So first we have to go do step 3. And to do step 3, I'm going to make a little table. Do my X values, my Y values. So my X is the number of days, and my Y value is the miles. So for me, if on day 0, so that would be my initial value, Mr. Toops can ride 6 miles. On day 1, he then doubles it, so 6 times 2 is 12. On day 2, he's going to double that. He's going to multiply the 12 by a 2 and get 24. And then on day, day 3, he's going to multiply the 24 by 2 and get a 48. So I left you on purpose a blank graph. You're going to have to make a scale that fits your word problem. So let's go count how many there are. I think there's 10, but we'll find out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to go by 2 so that maybe I can, maybe we'll go by 3s. We'll do 3s. So I'm going to do 3, 6, 9, 12, 15, 18, 21, 24. And then over here on my x-axis, I'm going to go by 1. So this would have been day 1, day 2, day 3. This was day 0. And then I'm going to graph my dots for my table that I just had. So my first ordered pairs on day 0, I can go 6 miles. And on day 1, I went 12 miles. On day 2, I went 24 miles. So you can see this graph is going to be very much off the screen or off the graph. And so it's going to look something like, keep in mind I'm not an artist, but do my best. Something like that. So there's my beautiful graph. And then we're going to go back over to our last square over here. And we're going to make some connections. So my y-intercept is my A value. It's right here on my graph, that blue circle I just made. So this was my y-intercept, and then I have, let me grab a different color. Forgot to do this. It said do your y-intercept. So there's my y-intercept. And my asymptote is right here along my x-axis. Okay, so back over here. So my y-intercept, intercepts are in ordered pairs. So my y-intercept is 0, 6, because that dot right there, I went over 0 and up 6. The equation of my asymptote right here is a horizontal line, so it should always be y equals, and on this line right here, y equals 0. So my answer right here is y equals 0. the domain of this graph, well, this graph goes forever from side to side, so its domain is going to be all real numbers. My range is always going to start from my asymptote and then go up or down. So for my range, I start right there where I put a star and I'm going up. And that value right there is 0. But I don't touch the 0. I get really close to it. So down here, my range is going to be y is greater than 0. And the last question is this growth or decay. So if you look at this, my thing's going up as I go from negative to positive across the graph. My graph's getting bigger, so this is definitely growth. And we also knew that because our b equaled 2, and 2 is greater than 1, so that made it be a growth problem as well. So hopefully this video helps you make your word problem, and then you'll draw yours. Please, honestly, don't copy it from somewhere. Make yours up and then complete this assignment.